Thank you for the lovely introduction. I am calling in from Naarm in Melbourne's north, where I run a small pilot facility where we take in local wastes and we transform that into new material products using mushrooms. So our business, Fungi Solutions, operates as a social enterprise where we're looking at regenerating local economies by adding value back into this waste that would otherwise be sent to landfill. This has the dual effect of sequestering carbon through the cultivation process and also producing sustainable alternatives to things like single-use plastics and polystyrenes. So this is an example of some of our materials used here as insulation from wine coolers that have been produced from local vineyard wastes through this process of Myco-Cycling. So we're really passionate about this circular economy solution. We don't think it makes any sense to have waste shipped around, shipped to landfill. These are really valuable resources that simply need to be harnessed and have some infrastructure put in place to recapture these valuable materials and convert them into mushroom materials. So we are a fairly new organisation. We've just been in operation for 1.5 years now. Our first year involved a lot of prototyping of the material and process to get it ready to scale up. I believe in Victoria alone, we have 1.52 million tonnes of organic waste that are being sent to landfill, which represents a huge economic opportunity if those can be recaptured. And we estimate that could inject an additional $1.1 billion of revenue into our local economy by capturing and diverting those materials. So the products we produce are known as myco-materials. They are a composite of the mycelium, which is the root network of a mushroom, instead of the fruiting body, and also a blend of agricultural waste in there, which provide the mushrooms with the nutrition source. This allows them to sort of be grown to form. We find it's a really rapid process. It takes just about 7 days to produce a mushroom material product. It's quite low impact as well, which is one of the things we love about this circular solution. Requires very little energy input. It's made entirely from waste. We currently produce our materials by hand with our small team, so it's still quite low emission as well at this stage, and ultimately produces a superior material byproduct that'll sit in for those plastic and polystyrene applications, but is fully compostable at the end of use. So this is a really new and interesting sector we call regenerative natural materials. These are materials that are nourishing at every stage of their life and offer circular solutions. So when we talk about the high compostability of these items, it means at the end of use, they can simply go into a home compost bin or be disposed of into green waste, where they are going to break down in around 6 weeks and aerate the soil, increase water retention, and also provide some nutrition back into that microbiome. So it's nourishing even after use, which is part of this elegant circular solution that we're really passionate about at Fundy Solutions. So this is an example of some of our material products. We're looking at ways that we can foster a circular economy infrastructure within Victoria, and we're looking at expanding out to other states as well. This basically involves pairing up with a network of community partners These could be people that have agricultural waste on their site or excesses from their production. They could be local businesses that have additional waste sources through their supply chains. And we divert those materials into new products. Primarily, that's a lot of packaging at the moment, but also have a few developing sort of areas in the construction industry, the food and beverage and produce industries, as well as sort of lifestyle applications as well. So anywhere that you might need to provide protective and insulating packaging, Myco materials have some really beautiful mechanical properties that make them ideal for applications where you might be using something like a synthetic foam. So they're highly thermally insulating, highly acoustically insulating, particularly at low frequencies. They are fire retardant up to about 300 degrees, which is a really interesting property that you don't see in the synthetics. Fully compostable, lightweight, and really durable as well. So they're performing quite well on the mechanical tests, and there's some development in the construction side of things as well to produce things like load-bearing mycelium. I think they're best for applications where you need that light, airy, protective sort of substance. Whereas there are some other natural materials that complement mycelium really nicely. So we're sort of seeing this space emerge of a cohort of natural materials that are all coming together to solve some sustainability challenges happening in a really broad variety of industries. So it's exciting to see that the scope of this new Myco-Cycling industry is quite vast, and it appears to us that it is a really good time to be scaling up this solution. So at our current 500 square metre facility in Thornbury, so far in our first year of operation, we've diverted 3,110 litres of organic waste from landfill. This has just been from businesses and organisations in our local area. This could be community gardens. We take in organic waste from restaurants, wine producers, breweries, and businesses that have things like cardboard and paper that they're looking to remove from their site. This equates to 418 kilograms of carbon equivalent sequestered through our Myco-Cycling program. This is based on a statistic from the Australian Water and Agriculture Department that has indicated that when this organic waste is going to landfill and decomposing, it's releasing 1.1 kilogram of CO2 equivalent for each kilogram disposed of. So it's a real interesting opportunity to do some carbon capture and also generate circular economy solutions as well. We also have quite a robust research and development department as part of our organisation. This is an example of one of our pilot projects that we're commencing in Melbourne and Wollongong with their councils. We've arranged for 138,000 cigarette butts to be collected. Currently there is no formal recycling program for this material. It either goes into landfill or pollutes our environments. Every cigarette butt can contaminate 50 litres of water just on its own. So there's quite an issue with this pollutant in particular. And we think there might be some opportunities to collaborate with fungi to see if we might be able to remediate some of this material and potentially produce a material byproduct from this process. So this is still a very early program, but one of the exciting areas that we're looking forward to seeing develop as a bit of a circular economy solution going forward. our collected cigarette butts have been taken from poles around Melbourne so far to date and collected from streets and waterways. We've then taken one of our fungi cultures and adapted it to digest the filter component of the cigarette butt. This material is a microplastic that is made from cellulose acetate. So because it has that cellulose in there, the fungi can access it as a food source. And over time, we're hoping that the adaptation of this strain will increase its efficacy in breaking some of the toxic components of the cigarette butt down, and prevent leaching and that sort of thing with this material. So that's just one sort of example of the exciting ways that fungi are sort of creating this emerging industry within Australia. We think Australia has real potential to become a world leader in resource management, and collaboration with fungi is a crucial part of that. So we're very passionate about this community model, particularly collaborative partnerships. So far, we are just a very small team of 5 at a rather small warehouse in Melbourne, but we're quite ready to sort of expand out these processes we've been developing over the past year and a half and see a larger scale facility developed. This is going to provide a blueprint for us to build out further facilities across Australia and start diverting those wastes from landfill and generating a positive impact for communities nationwide. So this is an example of the sort of biodesign that we do. We specialize in comprehensive and holistic product design, right from the very start of a prototype through to the end result in the manufacturing. So we're really passionate about this biodesign space and seeing where these materials can go to address a really broad variety of challenges in Australian economies. So our products are ideal for a really broad range of applications, but we see the scope of the impact that can be generated to be well beyond just the product applications. It's really about these flows of resources and creating value from them, but also putting materials out into the world that are beneficial and nourishing. Of course, addressing the challenges that all businesses face of having rising supply costs. So as these materials are made from waste sources, they're very low cost and competitive, but also provide some ongoing sort of secondary benefits to communities and individuals as well, which we really enjoy about the work we do. So I've absolutely powered through my slides in just 20 minutes. So I'm happy to open up for questions. If you have any queries about how the materials work or their applications or circular economy sort of spaces in general, I'm more than happy to answer those, and we can have a little bit of a discussion now.
Thank you very much. I did have one question from Shane Thomas, and it was,
yes.
Will the post office accept these packages or without them being further wrapped? Yes, they will. We find that most of our clients tend to have a cardboard outer and then a mycelium insert, is generally the way a lot of people are going. But this material is perfectly like a polystyrene box, and it's fully inert and a non-living material. So everything, once it's been cultivated and grown, is then heat treated
to just create a material composite. You can put on them, you can buy stickers, tape, all that sort of thing.
Very good. Warwick has asked, do you see big challenges ahead with scaling up to a commercial scale?
Yeah, it's certainly a very big challenge, particularly when you're looking at establishing brand new manufacturing structures. So there's not already that, I guess, system or guide in place. I believe that we are operating as the first commercially available mycelium products in Australia, particularly at scale. So yes, big challenges there, but one our team is really excited about solving. We're quite keen on collaborations that we're forming with government and council and other businesses and investors to come together to sort of form these sites and facilities. But it certainly is quite a upfront investment to get a site scaled. But we see that the volume of waste that can be processed by really refining that system and have it fully replicable anywhere is going to sort of help with the adoption, and also you know, generate a really competitive pricing for the materials as well, which is quite an important component of seeing that phase out of synthetic materials.
Because I guess that was always the challenge, wasn't it? I noticed that we've seen a lot of wonderful stuff in the lab, people starving mycelium to get them to digest plastic and so on and so forth. But the challenge has always been in upscaling. So accolades to you for getting to where you're at and for where you're going as well too. Another question, Peter Boronsky, sorry. And that was, what species of mycelium are you using?
So we use exclusively Australian fungi cultures. We have quite a broad range of cultures that we work with, and that's because we have a sister organisation that lives with us called My Community. So they're a citizen science organisation that are working in fungi, I guess, conservation. So we have paired up with them to create a culture library of Australian fungi, and then we look through that library and we cultivate it out for our research projects. So it's quite a broad range of species that we use, but we find things like the Australian reishi to be amazing for its bonding capacity, has extremely dense and almost rubbery mycelium, which is going to do some interesting things like increase the water resistance of your mycological products.
Well, that's a good segue into our next question, because I noticed that, yes, the reishi, the Ganoderma seems to be a popular species in this space, but Peter's next question was, then how do you stabilize materials where, for example, a house gets flooded or moisture gets into the house? So you were just talking about their ability to be moisture resilient?
Yes, yeah. So they are moisture resistant up to a point, particularly when you are able to cultivate a dense skin or hide on the outside. That's going to increase the water resistance. If you're just leaving your material raw and dried, it tends to, you know, provide resistance to water for a few days. And after that, you're going to start seeing it absorb some of that water, become softer, and then begin to deteriorate. So one of the keys for many applications with myco materials is our developing waterproof coatings that remain compostable and also work with the mycelium. Usually these are applied as surface treatments or something like that. So that's how we sort of get around applications that go against the sort of material properties of the mycelium just a little bit. I generally advise that the materials are used in applications where you're not going to be exposing them to humidity and water. So that's a real challenge for seeing them taken up in the construction industry. So that's still like an innovative area of the space.
Okay. Unlike plastics, which have a design life of infinity, damn them, I guess the intention is that these things will have a shorter design life and that they are compostable or decomposable. So to cut to the chase, what sort of design life would you give to something like one of your containers?
Well, it's so interesting because they're highly stable when they're dry. So if you're keeping them in a dry environment, they're pretty much going to last fairly indefinitely. They're, you know, a little delicate for too much sort of rubbing of the material that can deteriorate the surface skin. So if you're constantly shipping packaging boxes, they'll need to be turned over more often than something like a wall panel would need to be turned over, but at least minimum several months in hard use, several years in you know, a quiet sort of moisture-free environment, and then I'd say a couple of weeks if you're using them in more moisture-rich applications. So that lends itself to things like planters that we currently have in plastic, looking at something that can more effectively be dispersed into the soil. You'd want to harness that water retention quality that's eventually going to happen.
Very good. Vanessa had a question about collaboration with food companies or fast food restaurants. Have you operated in that space yet? Potentially with the view to replacing their packaging for takeout and delivery?
Absolutely. Probably one of the major sort of steps that's happening in that space is getting the materials food grade certified. So that's in the works, but it's quite a significant undertaking for a small business. So we're looking at a couple of partnerships to have that developed, but there is quite a lot of interest for the insulating and sort of protective properties in food and beverage industries. So that's sort of the major setback from seeing that certification be applied. But in my opinion, it's a fantastic application. On the flip side, with food and beverage industries, we're quite keen on seeing where the opportunities might be to take in their wastes as well to produce these materials. So things like food waste, we have one pilot project in with the Darebin Council that takes in local cafes and restaurants waste. It dehydrates it with a machine called an Enrich 360. And then that dehydrated material comes to us and is used as a nutritional supplement. So we like to sort of tackle the food and beverage industry from both sides.
Well, that's really exciting stuff, Amanda. I recently read an article about a small study, but it was from what I consider to be a reasonably reliable source. And I think it was The Guardian Australia. It was about a study that was conducted recently on a small sample. It was only 44 people, but they found that 10% of those people had microplastics in their bloodstream. That's human beings. So microplastics are a real and present threat to us as a species, and they're filtering their way from the bottom of the ecosystem all the way up. And I'm not sure if they're ever going to reach a critical mass for us, but it's frightening and terrifying to think that microplastics are already present in the bloodstreams of human beings. So it's fantastic to understand that we do have a viable alternative and that viable alternative is emerging. And I'm really excited that we've got people involved in that sort of space.
Absolutely, totally agree.
What was it that motivated you to get into all of this?
Oh, that's a good question. Was
it the fear of microplastics?
Well, yes, absolutely. That's a very real and tangible concern. Also, I felt that we spent so many resources making materials. I thought it was such a shame and completely devastating to be sending a significant portion of that to landfill. I don't personally believe that plastic in itself is a is necessarily a problem. It's the applications we've chosen to apply for it because we have other options, and it's things like cost cutting and mass scale mechanizations that have made plastic a really appealing material, when it's better in applications that we do want to last for 1,000 years and aren't exposed to our bodies and our food systems as much in our environments. So yes, I'm quite passionate about this space. I got into mushroom tech while I was in uni. I was looking for a way to recycle textile waste. So I was growing mushrooms on cotton scraps, for example. But it turns out mushrooms really aren't fussy about their food source. They'll eat literally anything, and the process is pretty much the same. So we found there was a really broad range of waste streams that we could potentially tackle.
I have another question from Penelope Sheridan, and I understand your processes are probably commercial and in confidence, but she's asked if you use any Rhizopus species in your fungi mix. Are you at liberty to disclose that sort of information?
We don't, though I'd be so curious to learn more about them. So if they're care to share any information with the group about that species group, that would be lovely.
Another question from Vanessa is, do you use a significant amount of water in your process? If so, how are you managing this if you want to spread throughout Australia?
Yeah, that's a really good question. We don't find it takes a great deal of hydration. We're not undergoing significant sterilization processes of our substrate, so we're not using autoclaves or boilers or anything like that. So I'd say that a lot of the water concerns come from cleaning molds and cleaning the space down, and then potentially a bit from hydrating the substrate. Where possible, we use things like grey water systems at our facilities to make sure that that's fully recycled, or circular engineering of sites so that that can be fed back into a compost or a garden. So you really want to make sure that that circular solution is embedded in the ethos of the scale up and the facility processes in general.
Fantastic. Peter Boronsky was asking, how does your product break down? Do fruiting bodies appear at the end of its life?
Sorry, could you repeat that?
I'm sorry, Peter Boronsky was asking, how does your product break down and do fruiting bodies appear at the end of its life?
Okay, so we're actually stopping our materials before they're fruiting. We have a certain percentage of the product that is not sort of viable to continue the cultivation process for materials. So we do actually fruit that material in fruiting chambers, and we've got a little social enterprise aspect to the business where any culinary mushrooms are donated to community kitchens or something like that. So it's a pretty small percentage of our products that are actually producing fruiting mushrooms, but it is a nice way to reuse some of our own waste within the facility. And then from there, that spent substrate is being composted at the end.
Wonderful. So exciting that it's only using 12% of the energy for plastic production and that it's a viable replacement for plastic. Have you ever had any collaboration with anyone from an organisation called No More Butts, which is
that's one of our wonderful community partners. So they are a charity partner. So their mission is to have a butt-free Australian environment by 2023, and I love a big bold mission like that. So we've partnered up with them, various councils. And that's where our cigarette butt remediation program has started. So we're really passionate about finding a way to recycle this really challenging and damaging waste stream. So far, so good. The mushrooms love the cigarette butts, and we're about to commence testing of the remaining residual ingredients and look at what we're doing with the heavy metals there. So your mycelium is likely to bioabsorb
heavy metals. So this could be one sort of outcome for the project, but yeah, we're looking at partnering up with some labs at the moment to have our remediated materials tested.
Good. Charmaine was suggesting it's a great idea to potentially use edible fungi and maybe then have a food source at the end of it as well too. But
yeah, we try to separate out the edible and culinary species of mushrooms from the remediation side of things. We just don't want any contamination or problems with uptake of toxins. But yeah, our edible side of the facility and our research and development side are on different wings.
Very good. Vanessa was asking if you've had any government support either through policy or grants.
We've had a couple of grants in our first year of operation. I think we might have been a little too early at that stage. You've really got to have some data and some proof points to be successful with larger sort of grant applications. But now we're going sort of into our second year of operation. I think we're really at the point where we'd be a bit more applicable towards some of those grants that are happening at the moment. So there's quite a lot in sustainability and circular economy and manufacturing, which is really exciting, and we'll be applying for some of those. We've also had a bit of success with awards, which has been primarily where we've had our support from. So we were awarded the Ones to Watch accolade from the Circle Awards and took home three awards from the Early Ethical Enterprise Awards last year, which was really lovely. Great vote of support from the community.
Rightly so too. Well done. I guess the idea Charmaine was suggesting, she got the idea from envelopes which she bought, which had flower seeds embedded, and you put them in the after and they grow flowers. So
yes.
Or,
yeah, that'd be so charming.
it would be nice. All right. Look, that's fantastic stuff you're doing, and thank you so much for everything you are doing. It's giving us a hope and giving us a reason to feel good about being involved in mycology as well.
Amazing. Thank you so much. Yeah, it's really exciting to see the field growing and blooming, and so many people getting excited and involved with fungi. People are always welcome to reach out to me if they have any questions, and yes, I absolutely will keep you all updated on the progress. We actually have a community network sign off on our website if anyone wants to stay super across the developments. We'll be posting everything up there.
Okay, thank you for coming and sharing with us, Amanda.
You're welcome. It's been such a pleasure.
Thank you.
All right. Thanks, everyone. Good night.